In this video, I want to show how we can do the FEA based optimization, human optimization. So given the inputs, now we can run the FEA model, generate the FEA model and get the output. So input, send it to FEA tool, which is FEM, get the outputs and evaluate the objective function, which I will explain later. Then find the cost of each design. Then you can do I don't know. You can do this step over and over again to find the best cost. So you can change this geometry. You can reduce the width of the magnet or height of the magnet or agate length, whatever. You need to find the optimal geometry that you want. So you can give the input here, send it to FEA, find the result out of it. For example, we want to build this system and we want to build it in cheaper cost, because then we can make more profit when we sell it. So first what I can do is calculate the volume of material I use, for example magnet and iron, by multiplying the thickness. Oh, okay. This is width and thickness and depth. Then I can calculate the weight by multiplying the density. Then if I know if this is available, the magnet cost in euro per kilogram, I can multiply this to get the total cost of magnet. Then if I do the same thing for iron and add these two, we now can calculate the cost of this pulling force system. Then say this fish is 2 kilogram. I want to make a system that can pull 2 kilogram of fish. We need have pulling force greater than 19.6 Newton. If the resulting force of this function is smaller than 19.6 Newton, then I can give penalty to our objective function. So in my objective function, I want to include the cost of the system and how much pulling force I can get out of the geometry. And if the pulling force is smaller than what we need, the minimum requirements, then I will give the penalty. Objective function is usually defined in a way to have to represent smaller value as a better design. So in the cost, the smaller the cost, the better. So you can use it to as it is. And pulling force, you can maybe inverse it to uh, uh, represent here. And also you can adjust the amount of penalty you will give to the objective function. So given these inputs, you will eventually have the output. So say this is function with these three inputs, then you can have a cost of the objective function. Then by repeating this process, you can find the best geometry that can pull 2 kilograms of fish with minimum amount of material, so that you can make more profit with uh, the fish game system. So if you do this by manually changing this number, it's okay. You are doing it, and it's time consuming, but you can still do it. If you do this process using algorithm, using code, you can automatically design the best best one. So we've seen how we can do FEA based optimization briefly. Now back to the resolver. What we will do is to design this reluctance variable resolver using FEA, combine it with generate the objective function with system requirements, and we will use some kind of algorithm called differential evolution to do this process automatically. So the next step we need to do is to measure these dimensions, generate a script, something like this, given the input geometry input variable.